chapter, that is solid state, and today we will be discussing in detail about the structure of sodium chloride. It is also known as rock salt structure. Sodium chloride or rock salt structure. So in today's class, we will be discussing about the structure of sodium chloride and other like graphite, diamond, copper, and here you need to learn certain facts. Okay, you have to remember certain facts. You have to learn them. So to begin with, sodium chloride. You know, sodium chloride, it consists of Na ion and Cl minus ions, and its radius ratio, that is R, radius of the cation by radius of the anion, is equal to 0.524. Okay, which suggests it is 0.524, which suggests that this sodium chloride will be having coordination number 6, and it has octahedral structure. So this is the first point that you have to remember. So in sodium chloride, it consists of Na plus ion and Cl minus ion. Radius ratio equals to 0.524. This suggests that this sodium chloride will be having coordination number 6 and will have octahedral structure. So the second point that you have to remember is the Cl minus ion. Okay, in sodium chloride, they have FC6 cubic closed packing, that is phase center, phase cubic closed packing. Okay, that is Cl minus has FCC. We have discussed about FCC, and here in FCC what happens? Each chloride ion are occupied at all the 8 corners of the cube and also at the center of 6 phases. 6 phases, please remember this. The next point that we have to remember is the sodium ion. The Na plus ion occupies the octahedral sites formed by Cl minus ion. Now see, in this structure in NaCl, Cl minus ion, they are present at all the 8 corners and also at the center of the phases. Therefore, there is certain vacant spaces in between, and that is known as what? Octahedral site. Why octahedral site? Because it has octahedral structure. Those octahedral sites, those vacant spaces, will be occupied by Na plus ion. Okay. Now here, as we have discussed, the coordination number of both Na plus and Cl minus is 6. So the next point that we have is now the number of chloride ions. The number of chloride ions that is required to form this cubic closed lattice is 14. So the fourth point is what? The number of Cl minus ions required to form cubic closed lattice is how much? Is 14. You have to remember this again. 14, and in the vacant spaces of this octahedral site, how many sodium ions are required? The sodium ions, now the number of Na plus ions required is how much? 13. Now this 13 of Na plus ion will be occupying which site? The octahedral site. Now the fifth point. So in today's class, there are certain facts that you have to remember. So here memorizing is a way. Now, the fifth point is the total number of ions. Okay, the total number of ions present per unit is the fifth point. The total number of ions present per unit cell is 8. Please don't forget, it's what? 8. 4 Na+ ions and 4 Cu- ions. Okay? And the last point that you have to remember is, now the number of molecules in unit structure. Now this is the total number of what? Ions present. Now the sixth point that you have to remember is the number of molecules. There is a difference between ions and molecules. The number of molecules present is what? 4. Because NaCl as a whole will make what? A molecule or one mole of the compound. So these are the certain facts that you have to remember about sodium chloride. This structure, okay, or it is also known as what? Rock salt structure. Example of this such type of structure also occurs in this silver fluoride, silver bromide, okay, ammonium chloride, etc. There are more examples in your book. You can have a look at that. Now let's discuss about metallic solids. Okay, within metallic solids, we will be discussing about crystal structure of copper metal. This was sodium chloride is what? Ionic solid. Now we are moving to metallic solid, and in that we are going to discuss about the structure of copper. Structure of copper metal. Now, here also what you have to remember. Now, crystal lattice of copper is made up of identical positive ions, okay, forming a close packed structure. So, number one point is what? It is crystal structure. Structure of copper is formed by crystal structure of copper is formed by identical positive ions. Okay? Identical positive ions. And number 2 point that you have to remember is it has FCC structure. FCC close packing. Face center cubic close packing. Okay? And number 3rd point that you have to remember is in this crystal system, the metal ions occupy the corners of the cube and the center of its faces. That you can know it from FCC. In FCC, what you have? These metal ions are present at the corners and also at the six faces, at the 8 corners and also at the center of 6 faces of the cube. Number 4 point that you have is, now here this point is very important. Each metal ion is surrounded by 12 other identical ions. So the next point is what? Each ion is surrounded by other 12 ions. Now how are we surrounding this particular ion? Now in the same plane. Now suppose this particular ion is lying here. This is the positively charged ion. This is the positive charge ion. Now in the same plane, it will be having 6 more. In the same plane, it will be having 6 more. 1, 2, 3, 4, 5, 6. See, this is lying on the plane of the board. Now one will be lying, the 6 will be lying on the same plane as this positively charged ion. The 3 will be lying above the plane, the other 3 will be lying below the plane. Okay? So these are the things that you have to remember from copper metal. So here you have to remember crystal structure of copper is formed by identical positive ions. It has face-centered cubic lattice, and each ion of copper is surrounded by 12 other ions. 6 of them will be lying on the same plane, 3 above the plane and 3 below the plane. Now let's move on to the structure of diamond. Structure of diamond. Now here you know about much more about diamond. Listen. Now here each carbon atom in diamond is sp3 hybridized. So I have taught you about hybridization. Wherever there is a single bond, then it's what? sp3 hybridized. Hybridized. Now here, what you have to remember the other points? The other points are, it also has what? It has FCC structure, or it has FCC face center, face cubic close packing. Okay? Packing. Number 3. Now here each carbon atom, it is bonded tetrahedrally. So each carbon atom is what? It is bonded tetrahedrally. Each carbon atom, okay? Each carbon atom in diamond is bonded tetrahedrally to other 4 carbon atoms. Okay? 2 other 4 carbon atoms. By what kind of bond? You know carbon always forms what? Carbon always forms covalent bond. So 4 carbon atoms by covalent bond. Please don't forget carbon. The most important point is what? Hybridization, sp2 hybridization. It has FCC, so close packing, and it has tetrahedral structure. Each carbon atom in this diamond is bonded tetrahedrally to 4 other carbon atoms. So you have to remember these points. And one more point that you have to remember is the coordination number. The coordination number of carbon in diamond is 4. So these are the points that you have to remember. Okay, you will be asked question based on these points. Now, since we have discussed about diamond, let's discuss about the allotrope of carbon. That is the other form of carbon, that is graphite. Now we are going to discuss about graphite. You know diamond, graphite. In your lower classes, you have learned what? Graphite is a good conductor of heat and electricity. Please don't forget this point, okay? So we'll be coming to that one. First, let's discuss about its hybridization. Number one, its hybridization. Each carbon atom in graphite. In diamond, it is acidity hybridized, but in graphite, this is the difference, okay? In graphite, each carbon atom in graphite is sp2. Please remember this point. sp2 hybridized. Hybridized. And now carbon atoms in graphite, it forms sheet-like structure. It has two sheets of structure which are separated by certain distances. Okay. Now graphite has two-dimensional sheet-like polymeric rings. So graphite has sheet-like structure forming polymeric rings, and these two sheets are separated by certain distance. You have to remember this point. And it has what? It has covalent bonds. It is bonded. Each carbon atom is bonded to other carbon atoms through covalent bonds. It forms covalent bonds and has hexagonal structure, okay? And it has what? It has hexagonal planar rings. It forms covalent bonds with other carbon atoms and has hexagonal rings. It has hexagonal planar rings. And as I told you at the beginning, it is a good conductor of heat and electricity. Why? So to this, let's explain why it has this. It is a good conductor of heat and electricity. It is because you know in graphite, each carbon is what? sp2 hybridized. Therefore, each carbon, one valence electron of each carbon atom is free to move from one point to other point. So here, whenever it is sp2 hybridized, what happens? Each valence electron is left with each carbon atom in this particular structure of graphite. Now, whenever you have this movable electrons, now they are responsible for carrying what? Heat as well as electricity. So these are the points that you have to remember from this particular topic. And we come to the end of today's class. We'll be discussing about defects, about stoichiometric defects in our next class. Till then, take care. Thank you.